Ladies and gentlemen, I'm Mr. DeRiggi. I currently teach sixth grade at Imagine Charter Schools of West Melbourne. I'm the math sixth grade teacher, and about 2 or 3 years ago, we introduced a curriculum known as Eureka Math, or commonly also known as EngageNY. Now, I understand a lot of the problems that people have with regards to the Common Core and stuff, and they say, this is how I learned math when I was a kid. This is not the math. I get it. I understand. And I understand and feel what you as parents are feeling. And you're kind of upset as to, this is not, this is not what the kids learn. Let me tell you from experience, it is. If you could see here, I have a brain surgery scar. About 3 years ago, I had brain surgery. When I came out of it, I was not very comfortable in regards to, how much I can read, how much math I could do. And this is when Common Core started coming out. And long story short, and I'm sorry, I'm congested, so my nose is like, oh man, all right? And plus, I'm filming this in my house, and I just turned the air conditioning on. Anyway. When I came into the brain surgery with the Common Core, I was like, all right, what is this new Common Core? What's the big deal? The Common Core is not new. It's been around for a while. And I'm going to do a video about that to explain the Common Core to you. The point of it all is this. You know your kids the best. It's the truth. Parents, guardians, whether you're from Mars or Pluto or Krypton, whatever, you know your students the best. Us as teachers are just, they're in their life for 1 year. But we need to know in that 1 year, what is the best way they can learn? So the whole idea with Common Core is that, maybe somebody can't memorize their multiplication facts. Maybe they still use their hands. Well, you know what? There are other ways to learn and do the math. And that's the whole point. So that's a video for another time. But what I'm doing here is I'm doing videos now to show where our lessons are in regards to the Eureka math. Hold on. There you go. You might be able to see me a little bit better. Hide my roommate's Pepsi cans. All right. So, let me go that way. There we go. So this is my first video. I've never done one of these before. I'm not even sure this is going to stay on the wall while I'm doing it. So I'm just going to do the best I can. We've been doing ratios and proportions. And to let you know that I'm putting the standards for Florida State right over on the right of me. Now, ratios are they're a pretty meaty module, okay? Basically, the two standards I'm covering are 6.RP, .1.2, and that says that understand the concept of a ratio using ratio language to describe a ratio relationship between two quantities. So basically what I've been telling the students is this: you have two things, and order always matters. And in your jobs, in the real world, think about it. If you're a nurse and you got 64 patients on your floor and they all need 2 things of Tylenol, it's a ratio of 64 to 2. And then, you can even, we'll simple it down when we talk about the value of a ratio. But that's your ratio. For every 64 patients on the floor, they get 2 pills of Tylenol. And, what about if, you're working in food? Well, with football season coming up, you got boneless wings. So if you got to order, there's 17 weeks, but let's go 16. 16 weeks in a football season. And you need to order 1,000 wings, 1,000 to 16. You break that down, you bring it down to its unit, the ratio value. How much is that per week? Okay. So I tell these kids, to find what's a constant. And that's why we talk about the ratio language. I have a word wall in my room, but I'm also adding a word sheet inside their notebooks. Parents, guardians, Plutonians, and Kryptonians. I just do that, as a joke in class. But I implore you to check your students' notebooks and make sure that they're taking accurate notes. It matters. I give open note tests every now and then because I like to, if a parent says, why did my student fail? Well, I ask, how can a student fail an open note test? The notes are right there. It's like the user manuals with my old video games that I had growing up. All right, but I put the example in the standard in the video description. The next one is 6.RP1.3. Use ratio and rate reasoning to solve real world and mathematical problems. And that's where this example comes on the board. I notice that there is a glare and it's coming from my lamp. Let me just move that. There we go. And that just made the glare go a little bit more. I'm so sorry. Like I said, it's my first time doing a video. And it's still there. Oh my gosh. Let me move it. Oh man. I'm so sorry, parents. There we go. All right. So I put a real life example on the board. Some of you work in jobs, and I tell the kids, math's everywhere. I got a kid who's very, very big into football. And I pointed out to him, if your team gets penalized on the first down, and there's 3 downs left, and they got 27 yards to go to a first down, what's the value of the ratio needed per down to get the first down? Basically we're talking 27-3, which is 9-3. And the kids started seeing how that could work. And I said, that's how you got to think. And I asked him who his favorite football player was. Odell Beckham Jr. Okay, Odell Beckham Jr. makes $24 million for 6 years. What is the ratio of his pay? 24-6. What is the value of the ratio for the years, in the contract? What's he getting paid yearly? The point is that ratios are everywhere. I used to work for Sony. I had to make, orders for products where I needed to know how much you're going, how many units of the PlayStation 4, how many of the TVs I'm going to sell, to certain stores. And I told the students, I was upset. I had to write people up. I had to tell people that they're not doing their job right because they couldn't do it right. And if you do ratios wrong, you're going to cost people money, which takes us to this example. All right, Module 10 says this. Module 1, Lesson 10. And the objective here is to identify patterns to complete ratio tables and find equivalent ratios. I'm going to apologize in advance, parents, guardians. The brain surgery screwed up the grip on my hands, so my handwriting is horrible. So I'm doing the best I can. I've been going to physical therapy and, writing as much as I can. I joke around and tell the kids I got C3PO hands. So I'm doing the best I can. So just follow me here, and here we go. Todd handed in the following payroll chart to his boss for the week. This might be loosely based on a true story. His boss told him to fix the error. What is the error? And how can it be fixed? So here is the payroll chart. Okay, here it is. And it says for 3 hours, the person got paid $24. All right, so basically you got to start to think 3 hours, how much is the person getting paid? And I show the kids, think about this. If you're mowing lawns or you're babysitting, this is applicable. Person worked 5 hours, they got paid $40. 7 hours, worked made $52. Worked 9 hours, made $72. Something is starting to not work out. Okay? Now, we did in Lesson 9 on Friday, and we discussed charts, constants. Well, the one thing we all see right here is that, 3 to 5 is actually, it could be +2. This is +2, and this is +2. So this makes sense that the constant, and remember, constants can be multiplied or added. I know in the notes I told the kids to multiply, but it's that old thing we grew up with. Whatever you do to the top, you do to the bottom. Whatever you do to one side, you do to the other. Whatever you do to one part of a ratio, you need to do it to the other. So with that being said, let's take a look, or it applies to the other. So 3, 5, 7, 9, you're adding 2, you're adding 2, you're adding 2. That is consistent. That makes sense. But then you got to look over here. And it says that for every 3 hours somebody works, they're going to get paid $24. Okay, wait a minute. So if I go to this and I do simple first and second grade math, 40 minus 24, okay, And I will break down how I do things. I'm going to do it right now. This is 440. It's really 4 10s. All right, 4 10s because you got 0 1s. Okay, maybe I'll make that a little bit bigger so you can see. I apologize. There we go. Let me make this a little bit bigger. Okay, I'll make it bigger for the video. So, oh my God, the teacher is actually showing how to subtract this? Yes, because I want you as parents and guardians to learn the language that the kids are learning today. And here it is. So here's the 40. Okay, let me get rid of this. Let me get rid of this. And we're subtracting 24. But what we're really doing is we're asking to take away 4 1s away from nothing and 2 10s away from 4 10s. And I tell the kids, break it down like money, because this can be done. You got 4 $10 bills, you can take away $2 bills. But if you're at the register and they say, well, I need 4 1s and you got nothing, what do? You need to degroup and break down one of the 10s. So now you have 3 10s and you break it down. You take that 10, here you go, sir, and he makes it 10 1s. Now you can take away the 1s. And you can do it one of 2 ways. You can just do it in your head. You know that 10 minus 4 is 6. Or you can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then just take away 4. 1, 2, 3, 4, and count. 1, 2, 3, 4, 5, 6. And that gives me 6. Or you can even do the traditional, this new method. That's not really new, but people have been doing it for years. Counting up. So you go 4. You say it out loud. 4, 5, 6, 7, 8, 9, 10. I got 6 fingers. So that must mean this is 6. 3 minus 2, we all know is 1. So this is plus 16. Now we're following the ratio table. This means this should also be plus 16. But you got to check. 52 minus 40. So let's get rid of our work, or let's put it over here. And this is where Todd's error came in place. Todd is probably not the best supervisor there is. So you got 2 1s minus nothing. That goes to 2. 5, take away 5 10s minus 4 10s. Now that's not plus 16. It's plus 12. And then you look here, and you got 72. How does a 52 go to a 72? Well, 50, and this is what I mean. Boys and girls, moms and dads. First grade math is showing up in 6th grade. 4 plus blank equals 10. Then you just reverse it. 10 minus 4 equals 6. Same thing here. 52 plus blank gives us 72. Well, I got to minus the 52 to find out what I'm missing. You got 2 1s, you take away 2 1s, you got 0. You got 7 10s, you take away 5. Now this is plus 20. So you look here. It worked here. This was consistent. This did not. So we're not adding. Our constant is not adding at all. So right there, there's a problem. The other thing is I told the kids, well, what about multiplying? Well, there's two ways to do the multiplying. You could ask, how does a 3 become a 5? How does a 24 become a 40? And some of you are in the head saying, but that doesn't make sense because a 3 becomes a 5 by multiplying by 1 point something. Okay, look at it like this. How does a 3 become a 24? Okay, it does it by times 8. Okay, how does a 5 become a 40? It does it by times 8. So far, so good. We're 2 for 2. How does a 7 become a 52? It doesn't. But what's the closest thing? Isn't there something that you multiply 7 by that can get you in the 50s? Some of you probably saying, well, 7 times 7 is 49. Okay, but Todd here said 52. So maybe there's something in between the 49, after the 49, that maybe, oh, wait a minute, let's add another group. So if it's 7 times 7 is 49, then let's make 7 times 8 is 50, is something else. So we'll figure it out in a second. But the times 8 here doesn't work. And I'll make that a sad face. But 9 times 8, because it worked here, I'm going to try it here, times 8 does equal 72. So now I found out that my constant, which is known as C, equals 8. So how do we fix this? So here's the question. What is the error? And I don't have enough room here on this board, But I would write down on the FSA that my error is Todd multiplied by 8 in level 1, level 2, and level 4, but he incorrectly multiplied by 8 in level 3. And then I would show the work over here. So hours over here, 3, 5, 7, 9, times 8, times 8, times 8, times 8. 3 to 8 is 24. 5 times 8 is 40. 7 times 8, 5, 6, 7, 8. That's how I do that. 56. 56. And 9 times 8 is 72. So what is the error? 52 hours should be 56 hours. Okay? How can it be fixed? By multiplying with the constant of 8 for every hours. Okay? So basically this means then, and this is going to take us into the next part of 6RP13, where they say that, well, here's the hours, here's his overall pay. This is really total pay. So now we're going to figure out the rate of pay. $8 an hour, $8 an hour, $8 an hour, $8 an hour. So the whole thing is finding where the glitches are inside the table and then fixing it over here. And that's where the homework, the problem set is going to be. And you could do division, you could do multiplication, but in the end, I always say that multiplication is probably the easiest. It's repeated addition. So I'm going to close this video. I hope it showed, how we're doing. I know some of you probably think this is basic elementary, but we are only in week 3 and we're only on lesson 10 of module 1. So we got plenty of time to go until we hit March 1st. Okay, the goal is to complete all modules by March 1st so that we can freshen up and do a review for the month of March and part of April for the FSA. Now, if you have any questions, let me know. But this is my first video. Any hints or anything underneath, let me know. I'm trying a new microphone out, so please, constructive criticism here. Comments are allowed, but keep it civil. All right? Have a great day. Have a wonderful day, and enjoy your Labor Day weekend. Adios.